Hello students, in this today's lecture we are going to study one very important topic from refraction part of chapter 10 light, that is refraction through a glass slab. Maybe we'll continue with refraction through a glass prism also today. First of all, you should know that this topic is why it is very important because this is there in your 10th class as well as it is a very important topic which you have in your 12th science physics textbook. Now let us first see what is glass slab. See, this solid structure which is made up of glass having 6 flat rectangular surfaces is called as a glass slab. So imagine that I have placed this glass like this and drawn the boundary. Okay. So this is made up of glass and its opposite sides are parallel. It has 6 flat surfaces. Now, if I draw this cross section of the glass slab A, B, C, D. I have given the name A, B, C, D to this cross section of the glass slab. So it is a glass slab placed in air. I have considered that a ray of light, incident ray here is PQ. A ray of light is incident here at the surface AB at this point Q. Okay, so this is my incident ray which is in air and I1 is the angle of incidence. We know that air is optically rarer medium when we compare it with glass and otherwise also in comparison to all other media excluding vacuum, it is always optically rarer. I hope you remember that. So when light enters from air into glass, when it enters from air into this glass slab, it means it is traveling from optically rarer medium into optically denser medium. And you have studied in the previous lecture, in that case this ray will bend towards the normal. This dotted line is a normal and this ray, had it been the same medium, no glass slab was there, then this PQ incident ray would have travelled along this dotted line, this path. But now there is a glass slab, so the medium changes, refraction takes place and the ray bends towards the normal. So this is my incident ray PQ and let this refracted ray be represented by QR. So this is my angle of refraction R1. So at Q point, I1 is the angle of incidence and R1 is the angle of refraction. Now the ray of light is travelling in this glass medium through this glass slab. When it reaches this surface of the slab, again it is going to come out into air. It means again it is going to change the medium. So again the refraction will take place at this point R and the ray, this is our incident ray now and it is going to bend away from the normal. Why away from the normal? Because now it is travelling from optically denser into optically rarer medium. So this is my incident ray. It is travelling away from the normal as it comes out of the slab. I hope you have understood this first of all ray diagram properly. PQ is my incident ray in air. At this point refraction takes place and the ray bends towards the normal. QR is my refracted ray and this R1 is the angle of refraction. At this point again refraction takes place but now from denser to rarer medium. I1, I2 is the angle of incidence here and R2 is the angle of refraction for this case. So there are two refractions that takes place here. Okay. Now this is the original direction of my incident ray. Now through the experiment we can prove that, otherwise I could have bent it little bit more also or little bit less also. But remember I have kept this ray parallel to the dotted produced incident ray because through experiment we can prove that this ray which comes out of the slab is always parallel to the incident ray and hence I have bent it in such a way it is bending away from the normal but it is parallel to the produced incident ray. Now we know that twice refraction takes place and we know which are incident and refracted rays for the two refractions. But still, when light passes through slab, we'll give special names to these rays. I'll call this PQ as incident ray, this QR as a refracted ray, and this RS is now called as emergent ray, as this ray emerges out of the glass slab. So I have named them incident, refracted and emergent rays. Now we see that this, what is this now dotted line? This is perpendicular distance between the refracted ray and incident ray. I have told you that through experiment we can prove that this ray, now we know this ray is emergent ray. Through the experiment we can prove that emergent ray and incident ray through the glass slab are always parallel. It means whenever a ray of light is incident obliquely at one of the surface of glass slab, from the opposite side it emerges out in such a way that it is parallel to the direction of incident ray. Now, this perpendicular distance between these two parallel rays, one is emergent ray, one is produced incident ray, is called as lateral shift or lateral displacement. So, there can be one question, what is lateral shift or lateral displacement? I have written the definition here. Lateral shift or lateral displacement is the perpendicular distance between the incident ray and emergent ray when light is incident obliquely on a glass slab. Now why obliquely I have written? Because if this ray is incident normally, we know that whenever ray is incident normally, there is no bending that takes place, and in that case light, if this would have been the direction of incident ray, then without bending it would have passed through the straight same path. So that's why it is necessary to mention here that lateral displacement is a perpendicular distance between the incident ray and emergent ray when light is incident obliquely on a glass slab. Now we can see here, students, initially I had written here I1, R1, I2, R2. So initially I had written this like I1, R1, I2, R2, but now I have changed these letters because this is now incident ray, so this I'll call it as angle of incidence, angle between the incident ray and the normal at the point of incidence. This I have named it as E because this is now angle of emergence, angle between the emergent ray and the normal at the point of emergence. Now these two angles, if we use maths, we see that we can prove that these two normals are parallel to each other, and so by alternate angle test these two angles are equal. So I have simply denoted it by R. Okay, so these two angles are equal. I have represented each of them by R. This is angle of incidence and this is angle of emergence. Since incident and refracted ray, they appear to be parallel, they are parallel to each other, so we can mathematically also prove that I is always equal to E. It means what? You should remember that whenever light, a ray of light passes through the slab obliquely, then emergent ray emerges out parallel to the direction of incident ray, and always I is equal to E. It means angle of incidence is always equal to angle of emergence. When you increase this I, this E will also increase in such manner that they both are always equal. And remember, this thickness AD is called as thickness of the glass slab. And this lateral displacement, this perpendicular distance, lateral shift or lateral displacement, it depends upon the thickness. If you increase the thickness of the glass slab, it means if you increase AD, then this perpendicular distance or lateral shift or lateral displacement will also increase. And this lateral displacement also depends upon this angle I. If you change I, always E will be equal to I, but if you increase I, this lateral displacement will also increase. So at least for time being, now at least you should remember that there are two factors on which lateral shift depends. Which are they? One, thickness of the glass slab, this AD, and secondly, angle of incidence. It depends directly on them. It means as you increase I, lateral shift will increase, or as you increase the thickness AD, this lateral shift will increase. And remember, through the glass slab, whenever refraction takes place, I is always equal to E. Hope you have understood this refraction through a glass slab properly. Now students, let us study refraction through a glass prism. You must have seen glass prism in your lower classes in the labs. Have a look at it. See, this is a glass prism. It has 3 rectangular surfaces and 2 triangular surfaces. Top and bottom surface are triangular and the sides are rectangular. Okay, so if I place the prism like this, I get a triangular cross section of the prism. Imagine that I am keeping it here on the board and drawing the boundary of this triangular boundary of this prism. Okay, it has to be made up of glass. Then we call it glass prism. Now students, when I place the glass prism here and suppose this is my incident ray. Again, remember that here all the 3 sides are same. I can choose any 2 sides in case of my prism. Okay, so here these 2 sides now AB and AC where the refraction takes place are called as refracting surfaces, AB and AC, because first have a look at the ray diagram properly. This is my incident ray, PQ. Here I have drawn the normal by using dotted lines. So this is my angle of incidence. Again I can see here that I have taken a ray which is incident obliquely at one surface of the prism. Now when it reaches here, again now it is going to enter into the glass prism. So it is going to enter from air because this prism is placed in air. So this incident ray is in air. As it strikes this surface at Q, it is going to enter into the denser medium glass. So obviously there will be refraction that takes place from rarer to denser. So the ray should bend towards the normal. PQ is the original path of the incident ray and I have just produced it by using dotted lines. Okay, and so the refraction takes place towards the normal. So this refraction has taken place towards the normal. It means I have to show the bending of refracted ray between this normal and between this incident ray's original direction. So now QR is my refracted ray. Just as in the case of slab, we had seen that twice refraction takes place. Here also again, now this becomes my incident ray and at this point the ray light is going to come out of the prism. It means again here the medium will change. So again the refraction takes place here. But now the ray is coming out from glass into air. So it is going to move from denser to optically rarer medium. So how the refraction will take place? I hope you remember that now when light moves from denser to rarer medium, the bending or the refraction should take place in such a way that the light should bend away from the normal. So this is my incident ray for this refraction at this point, and so the ray is bending away from the normal. This is my normal. This is my incident ray, the ray is bending away from the normal and I have shown this other refracted ray. So just as in the case of slab, at Q and R again the refraction takes place. I have chosen the similar names as I have chosen in slab, PQ, QR, RS. But again like slab, I will call this ray as my incident ray and this QR as my refracted ray. I have not written it here because otherwise it would have been hodgepodge here. So QR is my refracted ray and this RS is my emergent ray. Just as in the case of slab, we have given the similar names. Otherwise we know that for the refraction at Q, this is my incident ray, this is my refracted ray. for the refraction at R, this is my incident ray, this is my refracted ray. But overall, I'll call PQ as my incident ray now, QR as refracted ray, and RS as an emergent ray. Now in this slab, I gave the boundary name ABCD. Here I have 3 points of the boundary. I have given the name A, B, C. Now this is angle between the two refracting surfaces of the prism. Because in this prism, the refraction takes place at these two surfaces, I can call AB and AC to be the refracting surfaces, and angle between the two refracting surfaces of the prism is called as angle of prism. So I hope you have understood the definition of angle of prism. Angle of prism is the angle between the two refracting surfaces of the prism. And the surface which is opposite to angle A, that is called as base of the prism. It means this here in this figure we can call BC as the base. So surface opposite to angle of prism is called as base of the prism. Now again, instead of writing here this is I, angle of incidence, there is some little difference you will find here. Angle of incidence is I as in the case of slab. Angle of emergence is E as in the case of slab. We know that angle of emergence is angle between the emergent ray and the normal at the point of emergence, that is R. Now in the case of slab, these two angles, angle of refraction in first case and angle of incidence in the second case, they were always equal and we denoted it by simply R. But here they are different. Maybe they can be same in one particular special case, but here generally they are different, so I have used letters R1 and R2. Now in this case we can see that this is my incident, refracted, emergent ray. So here this is one angle, darkened one, denoted by delta, and I have named it as angle of deviation. Maybe in this diagram it is not very clear what is this delta. So I have again drawn this separately there. You can see I have produced this incident ray. I have drawn the produced incident ray there by using dotted line, this one. And this is my emergent ray RS. So I have drawn the emergent ray RS there. Now we know that these two rays will not meet. So what I have done, I have produced this emergent ray backwards. There also, RS ray is produced backwards. And I have got the point where the two rays appear to meet. Which one? Emergent ray and produced incident ray. They appear to meet at this point. Okay? And this angle delta is now which angle? It is the angle between the incident ray, obviously which I have produced, and the emergent ray. So this is angle of deviation. So I hope if the question is asked, define angle of deviation, you can define. It is denoted by delta generally. Angle of deviation is the angle between the incident ray and emergent ray when light passes through the glass prism. You should also write that. So angle of deviation is the angle between the incident ray and emergent ray when light passes through the prism, through the glass prism, okay, and when it is incident obliquely, that you should remember, when it is incident obliquely at one of the face of the prism. Now angle of prism, I hope you know, it is angle between the two refracting surfaces of the prism, and angle of deviation also is clear to you. See students, here when you change I, this E will also change. A is fixed, delta will also change, but how will they change? There is one relation which is fixed for glass prism. See, I have written there. A plus delta is always equal to I plus E. It means when you change I, delta and E will change in such manner that A plus delta is equal to I plus E. A is fixed for a prism, I you choose, and on the basis of so many factors, E and delta values take place in such manner that A plus delta is always equal to I plus E. Now this delta, angle of deviation, it depends upon which factors? These four factors. 1. Material of prism. We know it is made up of glass. Actually, it can be supposed it is made up of glass, but different glasses have different refractive index for a given color. So, delta depends upon material of prism, we have said, mentioned here. Color of light, incident ray may be of different color or indirectly may be of different frequency. Okay, color of light, it means if the color of light will change, keeping other things same, delta will again change. Or if you keep the color same and I and A same, but change the material of the prism, change the refractive index, again delta is going to change. Remember, delta depends upon four factors as I have shown here. 1. Angle of prism, 1. Angle of incidence, then color of light or frequency or wavelength of light used, and then material of prism, indirectly refractive index of prism. Okay, so delta depends upon four factors I have listed out here. Let us see important comparison between the refraction of light through a glass slab and through a glass prism. This is again one very important question which can come in board exams also. Now, first point is of difference, the most important point is when refraction of light takes place through a glass slab, incident ray and emergent rays are always parallel. Okay? Obviously, in both the cases you should remember that incident light is incident obliquely on the surface. This you should remember, that incident ray is not incident normally in both the cases. Then we shall just see the differences. Through the glass slab, incident ray and emergent ray are always parallel. Through the glass prism, incident ray and emergent rays are inclined to each other. That is, they are not parallel. Second point, through the glass slab, I is always equal to E. Angle of incidence is always equal to angle of emergence. And through the glass prism, A plus delta is always equal to I plus E. It means when you change I, the refraction will change, but E will always be equal to I. Similarly there, when you change I, maybe delta E will change, but A plus delta will always be equal to I plus E. These two are the major differences that you should remember when we consider refraction of a color of light or a ray of light through a glass slab. Now here you should know the definition of lateral displacement or lateral shift. That is a perpendicular distance between the incident ray and emergent ray when light is incident obliquely on the surface of the glass slab. Angle of deviation is angle between the incident ray and emergent ray when light passes through a glass prism. I hope you have understood refractions through a glass slab and a glass prism and understood the major or important differences between the two refractions. I hope this lecture is clear to you. Thank you, students.